So now we're going to do another equation problem. In this case, we're going to suppose that three consecutive odd integers add up to 135. Now we're also going to say that if three consecutive integers are added with the smallest being the smallest of the three above, what is the sum? So I want you to read that carefully and think about it for a moment. Think about what I'm really asking for. Suppose that three consecutive odd integers add up to 135. If three consecutive integers are added with the smallest being the smallest of the three above, what is the sum? So the first thing is we have to find out what is the smallest of the three consecutive odd integers that add up to 135. We need to know what that is. And then we have to calculate this second part, which is the sum of the consecutive integers, with the smallest one being the smallest number from the original setup. But these are consecutive integers, not consecutive odd integers. So I wrote this problem in such a way to force the reader to really think about the complexity of this problem. Okay, with that said, let's get started solving it. So excited. Okay. So the first thing I'm going to do is I'm going to start by writing down how you can express an odd integer. An odd integer can be expressed as 2n plus 1. So let's say that this is my first odd integer. Okay. Then the next integer, so if I were to just add 1 to it, I would not get an odd integer, I would get an even integer. So I have to add 2 to it to get the next odd integer. So if I do that, I know that my second odd integer will be 2n plus 3, and likewise 2n plus 5 will be my next odd integer. So this is my second odd integer, second consecutive odd integer, I should say. And this one's my third one. So both of these are so all three of these are consecutive odd integers. So now we're in a position to translate this first sentence into an equation, and in solving it to find some necessary information to solving the second half of the problem, which is what is asking us for an actual value for us to report. So what we know is that these three consecutive odd integers add up to 135. So we have that 2n plus 1 plus 2n plus 3 plus 2n plus 5 equals 135. Okay. We now combine the like terms on the left hand side and rewrite our equation like this. We have 2n plus 2n, which is 4n, plus 2n again is 6n. So on the left hand side we're going to have 6n plus 1 plus 3 is 4 plus 5 is 9. 6n plus 9 equals 135. Okay. Now we subtract this 9 over to the other side. Minus 9 minus 9. Okay. 135 minus 9, how would we do it? Well, 5 minus 9, we can't do it. So we borrow from the 3, leaving us a 2 here, and a 15. 15 minus 9 is 6. 0 minus 2 is 2. And then 1, we bring that down. This is equal, these go away, to 6n. We now divide both sides by the 6. Divide by 6, divide by 6. Well, that means 6 goes into 126, 21 times. 2 times 12 is, 2 times 6 is 12. We bring down our 6, 6 goes into 6 once, 21. So n equals 21, like this. So now we know, now notice what we got here. What we got here is n. So this is not even our smallest odd integer. We now have to plug it in here. 2 times our 21 plus 1 gives us 42 plus 1, which is 43. This then is the smallest of the 3 consecutive odd integers which sum to 35, 135. And so the reason why that is now significant is that we're then going to take that number and the 2 next ones that are consecutive, not consecutive odd, just consecutive, we're going to take their sum and that'll be the answer to the second half. So it'll be 43 plus 44 plus 45, which will give us 5 plus 4 is 9, plus 3 is 12, so we're going to put down the 2 and we're going to carry the 1. 1 plus 4 is 5, plus 4 is 9, plus 4 is 13, 132. So now we can say that the sum is 132. The sum is 132. Okay, perfect. Let me just briefly recap real quick because I think it's important to see everything that went on here. First of all, this sentence. Suppose that 3 consecutive odd integers add up to 135. We saw that we could represent an odd integer as 2n plus 1. And we also saw that to get the consecutive odd integer, we didn't add 1, we had to add 2. Because if we just go 1 forward from an odd, we get an even. And then the same thing here, we add 2 more to get the next consecutive odd number. So these 3 are 3 consecutive odd integers. And therefore, we're able to then write down the expression of the sum of these 3 odd integers adding up to 135, which is this algebraic relationship, this equation. We then solve that equation to get what the n is. The n is 21. But that n is not the least number in terms of the ones that satisfy the first statement. The least number that satisfies the first statement is the first odd integer, as we had originally described it. And what we do is we use our n value to figure out what that odd integer is. And that odd integer was 43. It then follows that we can read the second part. If 3 consecutive integers are added, with the smallest being the smallest of the 3 above, what is the sum? So here we have the smallest of the 3 above, 43, and we have the 44 and 45. These are our 3 consecutive integers, with the smallest one being the smallest of the 3 that we had originally calculated over here. And then we add them, and we get our sum 132. And that is why that is the correct answer for this problem. Ta-da! Magic. Magic.